All right, we are recording. Jesse, take it from here.
All right, great. Thank you so much. Well, and thank you very much for the invitation to come and speak to you all. I spoke to your group last year, a little over a year and a quarter ago or so, and since that time, I've joined the Vanderbilt Data Science Institute as their first chief data scientist, and wanted to talk today a little bit about AI in business, and wanted to start out by asking you all a few questions, and you can respond by along the bottom of the screen. You may notice that there's something called reactions. So if you find that, you can, if you're on the phone, you won't be able to do this, but if you can find the reactions, go ahead and click the thumbs up, and I'll get a sense of how many people have located their reactions. So thumbs up with many people, not everyone yet. Great, and then excellent. So many people have found their thumbs up. So I'd like to ask you just a few quick questions even before we get started. And so how many of you are currently using AI solutions in your business? So this could be you have a data science team, you're actually doing AI projects, or you're using okay, so let's do thumbs up for those who have AI projects underway right now. Okay, great. And then thumbs up if you're using a product that at least claims to have to use AI. Thumbs up if you're using a product, so this is a service you might be buying. Okay, great. Excellent. And then finally, how many of you are considering going down this path, but have not yet had the opportunity to do this? You're thinking of starting up projects. All right, so we have a nice mix. We have a nice mix of people who are currently using and applying, and those who are thinking about it. This is great. I hope that that folks will be willing to share some of their experience as we go through and as we talk a little bit about AI in business. So first, want to just mention a little bit about the Data Science Institute. We did start in 2018. And the idea is that we help data science grow both at Vanderbilt and also in our community. So we support research and collaboration. We do workshops. So we have workshops that we offer that are open for free to the community as well. I'll be letting you know about those about the end of the presentation. And we also we provide the opportunity to come in and talk to our data science team as well. If you're thinking of taking on new projects, if you are interested in discussing a little bit more about data science, the idea here is that you can come in for a free 1-hour consult, and if we are lucky, then it may work out that, that there might be an opportunity for one of our master's students to help you out with a project, or you might be interested in doing a collaboration with us. But at the very least, it gives us and gives our master's students who participate in these consults real-world experience with talking about and consulting on data science. So that's something that we offer up to folks in industry and in business to come in and talk to us. So we've had the opportunity to talk to a number of different businesses around town, and also with metro schools and with the State Department of Education, and with really a wide variety of groups over the last year. So today, wanted to talk about AI in of all of its different forms. We're going to start actually with some hands-on experience, with some examples you can try hands-on, just to point out some interesting newer developments and trends. Then we're going to go and we're going to talk more in depth about the trends and advances in data science that really have begun to shape the direction of future development in this field and what it means for business and for industry. And then, depending on interest, we'll take some more time to go through some of the pitfalls. So it sounds like some of you are already, sort of in and have things underway. Perhaps for you, but definitely for folks that are moving down that path. talking a little bit about how to avoid getting into some common traps in AI. But would like to answer questions at any time, so you now have the ability to unmute yourself. You can ask questions. You can put questions in text at any time. So really interested in answering your questions and making sure that we're doing things that are of interest to you. So then, before we dive into some hands-on examples, any questions or any questions before we even get started that you would like to make sure that we touch on? All right, then let's dive in. So AI really is a bit of a nebulous term, and it's actually recently started to be slapped on a lot of different areas. So I'm going to give you sort of my view of it, but do know that people will use the terms in different ways. AI, part of the challenge is that the very meaning of AI has changed over time. Back in the 1950s, people thought of AI as being specific problems to solve specific types of programs to solve specific types of problems, like the general problem solver, perceptron, which modeled a single neuron, expert systems. And then we actually did in the 1980s, for a brief period, have neural nets. But then it wasn't really until 1990s and 2000s that we started to get into stuff that really began to impact business. And so this was machine learning and gradient boosting. These were machine learning algorithms that actually could solve real-world problems and deal with large amounts of data and give you insight that previously hadn't really worked all that well in business. And so these are still probably the most commonly used tools in data science and in predictive analytics. But really, since about 2010, deep learning solutions have started to really come to the forefront. These have a lot more capabilities than the machine learning approaches, in that in machine learning approaches, you can think of it along the lines of you having to spoon feed the algorithm. So any features that might be important, you have to explicitly pull out of the data and then train the algorithm on those engineered features. To give you an idea, if you wanted to build something that used images, for example, and let's say that you wanted to build something and you wanted to determine how many people were building masks, were wearing masks in a crowd, and you wanted to be able to just make a quick estimate of how many people might be wearing masks. If you were to try to do that with machine learning, random forest, gradient boosting, logistic regression, you would have to separately design a program that could identify mask. So that's something you'd have to create. You'd have to code that up yourself. In deep learning, the game entirely changes. In that, you actually train it on images, and it figures out what the features are that indicate whether someone is wearing a mask or not. So in machine learning, it may be, all right, if I have two things that I think are an eye and a nose, or two eyes, can I see a mouth? And if you can't see a mouth, then there's probably a mask there. In the deep learning approach, you actually show images of faces with and without masks in different orientations and different lighting conditions, and the machine learning algorithm learns that feature itself. So it can learn based on data. You don't have to go and solve everything and code everything. It could do this for you. But there was a drawback, especially up until the last few years, and that is you needed to have a lot of training examples. Many training examples to get anything that worked out well. But then there was a breakthrough. There was a breakthrough for images, at least, and these were called convolutional neural nets. And the idea was that you had a pre-trained network that was already trained on many millions of images, and then you could use it to learn sort of that last mile, the last question that you had. You didn't have to train it to see. you could simply train it to, and you don't have to train it on faces. It could identify faces, but you just had to train it on the last little bit. And that's what pre-trained models have given us in the last few years. So a lot of development going on in deep learning, probably a magnitude greater research and development going on in the area of deep learning than in machine learning nowadays. Both still useful, but they solve different kinds of problems. So let's go ahead and try some of these deep neural nets online. So here, let me go ahead and I'm going to cancel my presentation. Come on, you. And there we go. Excellent. So what we're going to be doing is we're going to be trying out some deep neural nets. And what we're going to be doing here is giving you an idea of what creative kinds of things these deep neural nets can do. So this is an algorithm which can take different styles. So here we have different styles. So here we have a picture of, let's go and, so we have original picture of cats. That's the original picture. And we can say, I want to make this look like the Scream. All right, so we can do transfer learning, style transfer. So Van Gogh, I want to make this look like Van Gogh. All right. So this is a way to transfer styles. What's happening here, it's been trained on images, it's been trained on artists, and it learns the style of an artist through a creative approach called generative adversarial networks. So a network learns how to fake a Van Gogh. A network learns how to fake different styles of artists. And then what you can do is you can then apply that type of style to a picture. So actually, I have a couple of pictures that I wanted to try out here that just to see what they might look like. Have some pics here. I have a picture here of Jeff. So here's Jeff. Okay, Jeff. All right. This is something you might want to put up on your profile page. Let's go and do you as the Scream. Well, you know, that's a lot happier than they came across in the Scream. Let's go and do you. Let's see. Okay, there we go. I think actually this is the winning picture, but I don't want to just leave it with Jeff. Let's see who else I have here. Chad. All right, Chad. I have you. Okay. Yes. So this is a winner. So it's pretty interesting. You know, this is not just like changing, you know, to black and white picture or amping up. This is actually changing the style of what's being represented, which means that the AI has to know what's in the picture to begin with. So it's got to be able to apply these styles appropriately to the scene and to the information which is in the picture. So this is what's interesting about this. First thing that's interesting about this is these are changes that are not being made at the pixel level. They're being made at a much higher conceptual level. So networks have the ability to not just make changes sort of down here, but to make conceptual decisions, conceptual changes. The other thing which is interesting is that this entire network is running in my browser right now. So there is no backend. So this network, which started out huge and computationally expensive. They're very expensive to train. I mean, I'm going to be showing you a few models which took the power of a small city for several weeks to actually train. It took that much power. But once they're trained, then actually applying them, what's called inferencing, can be far lighter weight. And there are tricks that you can use. Those of you who are programmers are familiar with the idea of compilers. Something similar can happen with deep learning networks, where it can be compiled down, simplified, so it can actually run in your browser. Now, you may not be able to hear it right now, but my fan is absolutely running on my PC. I mean, I'm pushing my PC pretty hard, but it is running in the browser, which is pretty remarkable. All right, let's go and take a look at another one. So here, what we have is a quick draw. And the idea here is that it's a challenge. You're going to see how just how bad I am at drawing. And the challenge here is it's going to give me a topic and it's going to ask me to try to draw something. And then on the back end, the neural net is going to try to guess what I'm drawing. So when we do this, what I'll be drawing, and you can see what the neural network is guessing as I'm drawing. Okay? So let's go and we'll draw. Okay. I have to do a flying saucer in under 20 seconds. And as soon as the neural network guesses it, it's going to move on. So you'll have to watch sort of to see what it's guessing. But let's see if I can draw a flying saucer in under 20 seconds. Okay, so I have this.
I see sleeping bag, or pond,
Okay.
or bread. Oh, I know. It's flying saucer.
There we go. So it guessed flying saucer in here. I'm gonna change my. Did you all hear that, by the way, as well? Give me a thumbs up if you actually heard that. Okay, great. Yeah.
Yes.
All right. So camouflage. All right. I have no idea how to draw this. I wish I could pass this off to somebody else because I'm going to be terrible at this. All right, camouflage. So maybe a
I see line, or a
shirt.
fence, or a bow tie, or a sweater, or a bridge. I see zebra, or a jacket, or a mushroom. Oh, I know. It's camouflage.
All right, let's try one more. Oh, well, I did just draw a jacket. All right, I'll try this one more time.
I see elbow, or an envelope, or a sweater, or a t-shirt. I'm stumped. Oh, I know. It's jacket.
So a couple of interesting things about this. First of all, it's running in my network. It's running on my browser again. These are not high fidelity. These are not high fidelity images, right? These are terrible images that I drew. Where do you suppose the training data came from to train this up? What guesses do you have?
What domain? Internet?
Yeah, so internet, so you could search for things, absolutely. This is kind of specialized, isn't it, right? It's kind of like we have really terrible drawings. So you might be able to find some of those on the internet. Any other ideas of where they might be getting their training data from? I'll give you a hint. It's gotten better. So when this debuted a little over a year ago, I guess, its performance now is far better than it was before. So Jeff?
User interactions.
Oh, and Rob, so Sebastian, that's right. And also I saw Rob, everyone who uses the site, exactly. So this is interesting in that it is both, a game, but it's also collecting data and learning off the data because it told you what you're supposed to be drawing. You attempted to draw it, so then that final image that you have is an example of a correct training example. As terrible as you drew, this was a human's attempt at drawing what they suggested. So the idea here is, of course, that one possible approach when you're building AI solutions is you start with something that may not be that great, but it learns over time, it improves over time, and you actually collect additional data as you get to corrections. So if you can design a project in that way, then you can actually have incremental improvements over time until you have something which is really pretty remarkable. I don't know if you all would have been able to guess what I was trying to draw there, but it picked it up fairly quickly. Now let's go to something which is really now cutting edge. Everything we've talked about up to this point has been just with images. What we have now is, and I mentioned before that the early advances in pre-trained models was in images. So now we have something which is all about natural language processing. So here I'm going to go ahead and I'm going to restart this. I'm going to reload this. This is text generation. So what happens here is you type a sentence. So here I've typed artificial intelligence is changing business. In the future, decision makers, and then I leave off. And what I'm going to ask GPT-2, that's the name of this model to do, is to continue that in a meaningful way. All right, so what it came up with was artificial intelligence is changing business in the future. Decision makers will more and more rely on AI and machine learning ML algorithms as they will handle a significant proportion of what a business does. A company's ability to innovate is now an AI imperative. With the increasing usage of AI technology in all sectors, there's likely to be a substantial amount, let's have it continue generating, amount of supply-demand imbalance that will likely affect prices. So what's going on here? This model has been pre-trained on millions of examples of articles from across the web, Wikipedia articles, other documents on the web. And this is a great example of a pre-trained network that is able to do something that looks really creative. If you think about it, we can tie it back to what happened with images. So with images, pre-trained networks began to be trained on millions of images and therefore began to build up different features. And it began to build something which looked rather like your V1 visual cortex. So it began to build up simple features, and then it built up higher features like surrounds and gradients. And then even beyond that, it began to build representations for things that were in the images, like cars, grass, trees. Actually, there were nodes that would be associated with these types of higher level objects that might appear in the pictures. So in GPT-2, which is trained on documents, what began to happen as it's trained over time is that it began to build up concepts of words and of sentences and of ideas in the sentences. So here's how GPT-2 is trained. And this is what's really interesting about GPT-2, in addition to being just fun in and of itself. GPT-2 was trained to do the following thing. And this is what took a long time and took a small city's worth of power over a week to do. I'm going to give you some text. I'm going to give you text. For example, I'm going to give you, let's say that I've written a whole article on artificial intelligence. So artificial intelligence is changing business, let's say. But I'm going to ask you to guess the next letter. I'm going to stop it in the middle. I'm going to ask you to guess the next letter, and then the next letter, and the next letter. So if I were to do that to you right now, and I'm gonna have to pick out a book to see if you can do this. All right. So here's a phrase, and I want you to guess the next word. Actually, let's speed it up a little bit. There are situations where we might want. What's the next word? There are situations where we might want
to.
How did you know that?
Seemed reasonable.
Yeah, exactly. You're an English speaker, so that's right. But what other kinds of words might have fit there? Why did you say to in particular?
Just because first thing that came to mind as the word that typically follows will, or excuse me, want to do something.
Want to do something. And then John had an idea for options. So in order to answer that, you had to have the concepts that were the concepts having to do with the fact that want is a verb, and you might have an object after it, or you might have a helping verb after it. All of that is sort of deeply encoded. You weren't actually thinking in terms of, this might be a helping verb, right? I mean, you're thinking to sounds right. John, you were probably thinking, not along the lines of perhaps an object goes here. You were thinking, well, options kind of fits. So we have a language model which we've learned over time. And even though in school we studied syntax and we studied grammar and all of that, really we knew how to speak before then. And we learned through exposure. Well, GPT-2 learns through exposure as well. And it learns first at the sort of at the lower level, it learns about the idea of words. They're separated by spaces. Here are all the different words I know. Here are the different words, and this is kind of where they fit. And much like us when we were learning, we actually, if you look in there, you can find encodings that look rather like grammar. So it's learned grammar just through exposure. Now you can see where all that energy was going. It was a lot of training and a lot of GPUs for it to be able to begin to learn this. But if you want to do a really, really good job, now you actually have to know what people are talking about as well. You have to know the topics, the ideas. You have to have a general understanding of what's going on. And when I say artificial intelligence, that's the same thing as AI. So those are all things that GPT-2 had to learn. And so it could actually solve just that simple problem of guess the next letter. So, interesting thing here, models of this sort, GPT-2, there are other models that are similar, BERT, Roberta. When these models are turned around and sort of tested to get an idea of what higher level concepts they've learned, you find that they've learned things like scientific concepts. They've learned basics of mathematics. So you can ask them questions. You can turn it around a little bit and actually ask questions. Somebody had a great idea of seeing how well these models could do on the Regents exam, the 8th grade Regents exam for science for the state of New York. Because a lot of those questions are fill in the blank or complete the sentence, just to see how well it could do. And they passed. So the model passed. The model had encoded, it wasn't trained to know science, but it learned enough, and so it had those concepts encoded and could do well enough on those. So this one is most definitely not running in the browser. This one is running on a remote machine and is using even quite a few cycles even just to do what's called this inferencing, finishing the sentence for me. So GPT-2 and models like that do well on not just on language, but on anything where you have signals or information changing over time. So that's going to be something we're going to want to keep in mind, and then we're going to come back to that concept in just a moment. Let's go return to our slide deck, and let me make sure that what questions you might have. So what questions do you have before we continue on? All right, I'm going to go ahead and... All right. So let's talk a little bit about the trends and advances then. So a lot of the capability that we just saw, a lot of that is made possible through transfer learning. The idea here is that GPT-2 was not trained to finish people's sentences, to write people's stories for them, or to summarize. It was trained to guess just the next letter. So this is an example of transfer learning. It was trained on one task, but then we're able to turn it around and to use that pre-trained model in another context. That's one thing which has definitely been changing. More and more models are available that employ this transfer learning. Model frameworks is something else which is now changing, and we'll be talking about these as well. It's become easier and easier to use these types of models because now there are better and better frameworks to train up these models and to use them. And finally, transformers, GPT-2 and other models that are transformer-like, and we'll be talking about those as well. But let's go through these one by one. So, transfer learning. So pre-trained models, those models which are already trained on images, require far less data. So that solves the problem that we had with deep learning models before, where you had to have a ton of data before you could even get to first base. Used to be, if you wanted to use a deep learning model that was great, but you needed to have hundreds of thousands, if not millions of examples before you could train something out to do something useful. Now, you can pick up a model off the shelf and actually begin to use it to solve real-world problems. The other thing which is interesting about and useful about deep learning models is you can solve one problem. Solving one problem might partially solve another problem. One of my favorite examples of this is through chatbots. So Raza is a chatbot framework which you can use to actually build chatbots either using text. You can also use it as a sort of a backend use verbal models as well. With this, they built this on top of deep learning models. And the advantage that they got from building all of their work on deep learning models was that the very first time that they had to build and to train a chatbot is effortful. So a chatbot, for example, on taking reservations for hotels. So they built a chatbot. They trained it on all the intentions of people calling and the proper responses. But because this was built on a deep learning model, the model was not only learning just the exact sort of by rote responses, it was also learning things like the concept of reservation, the concept of cancel, of reschedule. So taking this model, which was trained on hotels, they were able to, with and that required many, many training examples to get this first one up and running. They're able then to apply it to airline reservations. And there they needed far, far fewer training examples because now there was already the concept of cancellation, of booking, of changing time. All of those were there. And so that retraining of the chatbot to work really well for airline reservations required less data and was faster to do. So Kevin, you had a question. Are most models open source or are models being built to sell? Both. But there are actually a lot of open source models, especially around that come out of research groups. And often groups like Facebook and Google will eventually open source theirs. It's kind of funny, OpenAI, which built GPT-2, has released their source code a bit later, but they are releasing it as well. It requires some work, so it's not a completed process, a completed project that you can just sort of plug in, but you can often go and get the code, and with a data science team or with a good data scientist, actually use these for solutions. I'll show you an example of one actually that I was able to build on just a few lines of code. So a next trend in advance that has been really important has been the dawn of mature model frameworks. So here's the problem. Putting these solutions in production is really expensive. So let's take a look at the data science project life cycle. So when you're building a data science solution, people tend to think of and only concentrate on this part. And this part's hard. This takes time. Even getting your problem definition right requires some iteration. You'll define your problem. You think that you're in data exploration. You realize, you don't have enough the right data to solve your problem. You have to come back here. When you're in this loop right here, you find maybe your model isn't working as well as you need it to, so it might cause you to go all the way back here. People tend to forget, actually, that there's whole additional step, and that is deployment. So deployment, it turns out, can be rather difficult. If you think about it, you probably are still continuing this work, right? So you're probably at least iterating here, which means that you'll want to put different models into production. This means you want to have a way to score these things and actually have these things run to give value and to be able to deliver these types of predictions or however you're using it. And it turns out deployment's really tough to do, and it's tough to keep track of exactly which version model you're on. All of those things are very difficult. And what happened up until just a few years ago is companies always tended to just build their own solutions. So what they really wanted to be doing was actually putting things in deployment, and instead they were just building an entire framework to support all this work. Well, now there are frameworks which make this much simpler. So there are frameworks which support the creation of models. There are frameworks which make it much simpler to deploy models and actually make them available for people to use. It's greatly speeded up the work and the return on investment, improve the return on investment for data science teams. Because data science teams will build great solutions, and then leaders would be looking for these to be in production, and it would be a year before they actually saw the results. Very, very painful. And John had a question, what is the best strategy to validate and to test after data exploration? Actually, that's a really good question. I have a particular view about how you actually evaluate that. And I like to define my problem from the very first. When I am actually defining my problem, I like to define my problem with a metric. So the idea here is that you define your problem well enough so you can actually put a value on the decisions that would be made on this particular solution. So let's say that you're trying to do employee retention. So you're doing employee retention. How much would you save if you were able to identify an employee who was about to leave? What interventions could you put into place? How well do the interventions work? How much do the interventions cost? How much does it cost you if the person leaves? So by doing that, you can then sort of scope and size what the opportunity is before you get started. And then right away, when you get to the point where you build your first model, you go through your first iteration, you can then make a dollar evaluation of what the value of this model is. So then the question is, how can you validate? You actually run on historical data that you were never trained on, and you're able to say how much this model is worth. If the model, I've had models before that I thought were terrible. The accuracy was really low, but when I ran the numbers, they were better than, when I ran the numbers, it still provided some support to decision makers. Had one model that was worth $30 million to a company, $30 million a year, even though I thought it was a terrible model, but it was providing some insight and it changed decision making enough. And when I ran the simulation, reran the previous year's data on data that I'd not trained on, and actually ran through and put into place the model and simulated the effect of the decision making being based on the model, it was worth a lot. So what that tells you is your investment a good investment very early on? Whether there's even enough opportunity to move forward. It also weeds out those problems that are not well defined enough to even move forward. Because if you can't define your problem well enough to quantify what it's worth, if you can't say how it's going to be used in the decision making or in the business making, you probably shouldn't be doing it. It also tells you when you need to stop this iteration. Data scientists can work this, for as long as you get them, because they're always able to improve the model just a little bit. They're always able to improve it some. And the trick is, when do you stop? And what this tells you is, well, over the last week's worth of work, you improved the model $1,000 a year. You really need to stop because we're spending a lot more and we're never going to get that value back. And so it tells you we need to move in. It also helps you decide how much you're going to spend on deployment. If something is only going to be worth $50,000 a year and it's cost you $200 to deploy it, are you willing to wait for 4 years to get your money back? If not, do another project or have another project that's also going to be using that same delivery mechanism. And finally, John, you also had a question. And John, you can get back to me and let me know if I answered your question. John, you also asked, deployment on-premise versus cloud, which path is easier? There are some very nice frameworks that are sort of end-to-end frameworks that Azure has, AWS has SageMaker, not quite as end-to-end. IBM has some solutions. So it sort of depends on how different your solutions are going to be. If you're going to be building something which looks very different and which is more deep learning than machine learning, you might need to be on-prem if you're building those types of unusual types of solutions. But if If your solution is one that is offered as a push button solution, feed in your data, train the network. If you're able to do something like Azure or IBM, that is like single button deploy. Data robot, same thing. So once you get it trained, deployment is much simpler if you're able to do that. And I'll be happy to talk more in depth about those as well. Any other questions before we move on? All right. Trends and advances. Some new frameworks, the ones that are on-prem or can be cloud-based that have to do more with the data science and with deploying models. MLflow is a good open source solution. So Kevin, you were asking about open source versus paid. Azure, Data Robot, those are sort of absolutely paid solutions. MLflow is an open source solution, so it's one that you sort of have to stand up, but it allows you to put some nice infrastructure in place. And then, of course, any of the turnkey systems that can provide that push button to production. So trends and advances, transformers. So we talked about GPT-2, and I mentioned BERT and Roberta. And just to reiterate, and just to remind you, these are types of models that do self-supervised learning. They do training on a strange kind of task, like guess the next letter in this sentence, guess the next letter in this document. And with intensive training over time, the network begins to uncover the patterns and the meaning from the text. So for models like GPT-2 and BERT and Roberta, it begins to learn the concepts of word types, of cases, of verbs, of different types of verbs, and then the concepts on top of those, and then so you have a whole hierarchy of meaning all the way up until it has encoded some concept of science and math and history and geography. It has these things encoded. It's not a genius, and it gets some things wrong, but it's in the neighborhood of. What's really happening, though, is it's really just uncovering patterns and meaning from serial information. So that means whenever you have data which you can sort of read, then it can begin to uncover the meaning from that. So one interesting use in science is applying these types of models to DNA sequences. And there's been some nice success there to actually uncover what's being encoded in the DNA over time by training on this serial information. The other thing which is interesting is applying this to images. So different way of thinking about images, but if you think about it, if you take an image and you simply sort of read it pixel by pixel, and then you go down to the next level and then you read it pixel by pixel, that is serial information. It's inline. So what if you fed something like GPT-2 a lot of information about images, but you actually fed it, just a piece at a time, a pixel at a time? Could it actually begin to learn and be able to operate and be useful? And the answer is actually yes. So here's a nice visualization, and this is work from OpenAI, which sort of gets across this idea of using GPT-2 to, let's go and see if I can get this to run, and I won't be able to get this to run, but it scans images and actually begins to uncover, much like convolutional neural nets, it can begin to uncover meaning. And this is a great example of self-supervised learning. Simple task which seems to be unrelated to what you were trying to learn, but actually you can learn quite well what's in an image by reading it pixel by pixel. And this allows you to do things like fill in images. It allows you to train up something that can learn about the objects that are in images. So trends and advances. I know we mentioned transfer learning and frameworks before, but combining these two are actually really powerful, because now you have pre-trained networks, so you don't have to do a lot of work to get something trained up. And second, you have frameworks, so it's much easier actually to create these and to put these into production. So I'm going to show you actually code that actually trains up 2 different neural nets. And I call it, these are bears and professors. So here what I wanted to do was be able to train a network that could differentiate between different types of bears, that could differentiate between grizzly, and actually I think that's the grizzly, that could differentiate between grizzly, brown, and teddy bears. That's one. So I wanted to train up a network where I could just show it an image and it would tell me it's grizzly, brown, or teddy. And then I also wanted to train up a network that would tell me, at least make a guess about whether, based on a professor's image on their website, what area they were in, psychology, art history, how well could it do? So here's the code that I wrote for the bears. And this is its code in its entirety. So the whole first part is really just getting to the point where it is defining where the data is. And then what it does is it actually managed all the data for me. And then in a single sentence, a single call, I create, and that CNN stands for convolutional neural net. It actually took a pre-trained network, it's called ResNet34, and trained up a network that had near perfect performance. And all I had to do was find a whole bunch of pictures. So I found about 200 pictures of bears online, trained it on that, and then now I have a bear detector. And that was the sum total of the work that I needed to do. So I did the same thing with professors, and all I had to do was create a new listing. And so now instead of just Teddy's, Grizzly, and Black, now I have archaeology, art history, chemistry, comp sci. So I have now a folder with a bunch of pictures of professors labeled such that they're labeled with what field they're in, and then everything else is the same. All the rest of the code is the same. The only code which is different is really the data that it's trained on. So now I took something which 5 years ago, maybe 6 years ago, would have been PhD level stuff. If I could have gotten a professor identification program running, that's dissertation level work right there. So that means that's like 6 years, or I'd say 3 to 4 years worth of work. And I'm able to do it now with a couple of lines of code. And frankly, it took me about 2 hours to do that. So the world is changing because of pre-trained networks and because of these frameworks which allow us to put models into production. All right, let me go and pause here. What questions do you have about any of the advances or trends that we've talked about, or any of the models that we've talked about so far? What we'll do is we'll send out a link to where actually you can find and play with some of these and try them out for yourself. I want to have a show of hands, if I could. Well, actually, let me go ahead and mention a few things first real quickly. If you're interested in learning a little bit more about what we were just talking about, evaluating and coming up with the value proposition for your data science efforts, I'd like to invite you to the National Analytics Summit. I'm going to be giving a workshop there. I'll be on the very first day on September 21st. This is going to be a virtual workshop this year. And this is going to be a hands-on workshop, so you'll actually have time to try some things out. We'll be probably using the employee retention model, but you'll be I'll give you a pre-trained network for you to actually train up, and you'll be trying to come up with some good evaluation of how much this might be worth to you. So it's hands-on, and we're going to be determining the dollar value and actually be going through this. I hope it's useful to you, but I invite you to that National Analytics Summit. And also, like to invite you to come for consultations, with my group. This is my data science team, Ben Lane and Dr. Shara Bell. We'd love to be able to talk to you. Let me go ahead and pause here again for, I want to get a thumbs up here because we have about 19 minutes left. I have some traps that you might get caught in with data science projects. And I would be happy to go through the 5 traps that I think are the 5 most, the 5 deadliest traps, or can open it up for question and answer. So what would you all like? Give a thumbs up if you would like to go through the traps. All right, and we'll let those thumbs up fade away. I think that was majority of people, but we'll double check. How many people instead would like to have open Q&A right now? All right, let's do the traps. So, first trap, I'm cheating a little bit. It's actually 2 traps, but they're related. And I call this the perfect child or shaving the yak. The idea here is that the perfect child is our data is in great shape. Usually senior leadership believes this, where your data is just in great shape, but in actuality, it's not. It's troublesome. There are errors in it, and it's difficult to get very much done. The second related one is, and everyone knows that the data is a mess, and therefore, before you can do anything, you have to clean it. You have to build the infrastructure. You have to fix the processes. So how many people have either been in the trap where leadership believes that the data is in great shape and you ought to be able to do more than you can? So give a thumbs up if you might have been in a similar situation, or if you're in the situation where your data is a mess and you don't feel like you can do anything because your data is a mess. So a couple of people in the first trap, a couple of people in the second trap. So then how do you get out of this? An important way to get out of this is to do valuation of projects before you actually start them, and figure out which projects can actually be done given the restrictions that you have. So you recall before we talked a little bit about talked about defining the problem early on. So the solution to a lot of these is good problem definition beforehand, and then seeing you may have crummy data, but how well can your data work? Remember, data doesn't have to be perfect to build a data science solution. What will often happen is your model just won't work as well. So does it work so poorly that you're not even going to do your project? Well, do your first model. Get an evaluation of the value of it, and then you can make the decision whether it would pay for you to go ahead and fix your problems because the model would be worth so much more. Evaluating your solutions that you have and coming up with a dollar amount, even if it's just a ballpark figure, and that tells you whether you really should be spending all that money to fix the data. Maybe there's not enough opportunity there and you're just going to run with what you have. Data whisperer. So here the trap is, again, often leadership or more generally in the organization, people believe that data scientists are data whisperers, and a data scientist can figure out what the data is telling us. So how many of you have been in a position where, and you don't have to say which, where you either asked a data scientist to tell you what the data, to say what the data was telling you, or as someone who was working with data, were asked to figure out what the data was telling you without much other guidance? Sean, I know you have. Okay. So how to get out of this trap? This requires a little bit of fortitude, but I actually refuse to go into data science projects unless we have a definition to begin with. I've tried jumping into these before, and it's very difficult to actually meet the expectations, because the expectations are sky high here. So learning how to get into good conversation about defining problems makes all the difference in the world here. Trap number 3, magical thinking. And this is AI will solve all of our problems. This trap actually comes from a bit of a misunderstanding about data science and AI in general. So you've seen that AI is very good and can do some things that certainly seem kind of magical, but really what's happening is it learns something very deeply. So sometimes when people think about AI, they think about general AI. So they think AI is wide and that AI can reason and can solve ill-posed problems. When in actuality, AI is very good at learning very specific domains and sometimes very deeply. So it learned guessing the next character so well that it actually had to learn, the basics of science and history and geography just so it could guess that next letter. However, if you asked it to reason or to solve an ill-posed problem, it wouldn't be able to do much. So part of getting out of this trap is messaging what data, what this is good for, what AI is good for, what it can solve and what it can't solve, and also how much it actually costs. And Russ, I missed this before. Just because leadership thinks it's in good shape doesn't mean that it is in good shape. Absolutely. This goes back to the perfect child and shaving the yak problem. And also, Kevin, you had a question earlier that I missed. I'm sorry. How close are we being models to create realistic videos of a person speaking? We are there. It's a huge problem. You can absolutely create a realistic video of people speaking. So spoofed videos are now a thing. All right. Trap number 4. Diving in headfirst. Let's hire a data science team, and let's see what we can do. How many people have been caught in this trap? And this requires some self-disclosures. That's why I like to have the voting buttons before, because you don't actually have to self-disclose. This is, and I'll raise my hand too, absolutely. I'm like, hey, we'll get the team. You build it and then they will come. Well, actually, that's a tough thing to do. Data scientists tend to be expensive hires, and unless you have an idea of what types of problems you want them to solve, you may not know which kind of data scientist to hire. It turns out there are many different types of data scientists. You might have a data scientist that is an expert in machine learning, but actually doesn't know that much about deep learning. So knows machine learning, doesn't know deep learning. So if you have a project which actually would really benefit from something like advanced natural language processing, you've now hired the wrong person. So defining the projects and evaluating the projects, at least to the point where you know what the opportunity is for the possible projects before you actually hire someone, is a huge step. Then you can get an idea of the types of things you want them to do, the scope of the work. It may be that you're earlier on in your journey and you need someone who's really a strong programmer, a strong engineer, so they can help build out some of the things and also move you towards data science. Very different kind of person than one who is going to be building you deep learning solutions. All right, and the last trap we'll touch on. You want to hire the unicorn. You want to hire the data scientist that knows it all. So I tend to think of data scientists as having a set of related skills. So statistics and mathematics, visualization, communication, storytelling, domain knowledge, big data, depending on where you are, you may need this, programming, SQL, machine learning, deep learning. And what people think is that they want to hire this person. They want to hire the person who is a master of all. But the fact is, especially if this is your first hire, the fact is this data scientist can still only do about one thing at a time. So even though they have the ability to do all these different things, if you actually need someone to be building your back end for you a little bit, then it's going to turn out that this person is going to be spending all of their time doing just programming. So that means all of these things are going to be just wasted skill sets. You're still paying for them because you're paying for this person who has all this experience, and you're probably paying East or West Coast prices for this person, but you're having them do just one thing at a time. So what I often suggest is, again, define your projects, get an idea of the opportunities or in those projects, the total dollar value, and then begin to hire people who look a little bit more like this. And the trick here is it's a lot cheaper to hire someone who is kind of like this, and then you hire another person who can perhaps fill in their areas where they're not quite as strong. So you hire someone who perhaps is strong in statistics and visualization, and who has these others' ability. And then what you can do is you actually put these people together, and you form a team, and the team itself has those skill sets that you need. So you layer one on top of the other. You have individuals who have complementary skill sets, and that way you can get more than one thing done at a time, and usually lower cost than hiring a single person who may know everything but can still only do one thing at a time. So this is hunting for the unicorn, and probably the worst thing that can happen to you is you actually find your unicorn, and then you hire them, and you don't get what you need out of your data science team. All right, so I'd like to open this up for questions, and then I will leave you with my contact information. So what additional questions do you have? Or I have a question for you, actually, and I'd like for you to share on chat or speak up. What traps did I leave out that you think are ones that I should include?
So this is John Smith with Change Healthcare. Jesse, thank you so much. Wonderful presentation. Obviously, we've just dipped our toe into the topic, but very well presented and insightful from my perspective. One thing, I don't know if this is a trap or not, but Jeff and his firm and I met today talking about the large set of new players as it relates to AI technology and its influence or impact in software development. And so he talked about the length it takes for them to mature. They may have been around for 2 years in order to reach a plateau and to flatten and to start adding value. It may take another 5 to 10 years. So I don't know how you would frame that as far as a trap, but I think it was definitely one I didn't consider until I heard it this morning. Yeah.
So, and sort of a couple of really interesting things that you mentioned in there too. Yeah, waiting for knowing whether something is mature enough to be able to. And tell me if I've gotten this right. To be sure enough to be able to be able to adopt it, and sort of knowing where they are. I certainly personally have fallen into the trap where. I thought companies were further along than they were, but it turns out there's critical pieces that were missing. This was especially true for frameworks. That was true for years. Where just you think that you have the whole thing, and then you realize, oh, there's a critical piece which is missing, which really then just just erases the value of everything else. You also mentioned something else which was interesting there, which was coding, and that was one thing I didn't mention here. But if you think about it. Way back here with this idea of transformers learning, uncovering patterns and meaning from serial information. One of the interesting applications is having a GPT-2 type solution trained on computer programs, and it turns out it does really well. So you start typing a description of what a function should do in a program, and it begins to code for you using the variables that you had previously, fill in sort of, essentially what that function ought to be doing. It's truly automated programming, made possible because of this deep hierarchical knowledge of, okay, oh, this is, I have the concept of a loop. I have the concept of a loop that, for which it needs to have a conditional end, so it begins to build these representations as well. Yeah.
Fantastic. That is amazing. I will research additionally. So thank you so much.
Yeah. One of those technologies that's still early, but it's there and it's coming. Great question. Thank you. other questions? And Rob, yeah, thank you very much. Let me leave you with my contact information here. Please feel free to reach out and join us for some of our workshops, or set up a time to come and meet with me and the team and one of our master's students as well. So you can reach out to me. You can visit our webpage, but do feel free to email. We'll get you on our list for our lunch and learns.
Awesome, Jesse. Thanks again for taking the time to chat with us today. As always, it's amazing to hear the updates around this area, straight from the horse's mouth. So congratulations on everything you're doing at Vanderbilt, and definitely as an organization, the TLN, keep us in the loop on how we can help support you guys and what you're doing there at Vanderbilt. Always happy to help any way we can. Thanks everybody that joined. Again, just a reminder, this presentation will be on TLN once my tech marketing team puts some title slides and fancies it up a little bit. So it'll be on the YouTube channel, so be on the lookout for that. And before we go, does anyone have any questions or comments or anything additional for Jesse before we break and get the rest of the day back to us? Very good. Well, thanks everybody for joining. Thanks again, Jesse. I hope you all have a great rest of the day.
Thank you, everybody.
All right, take care.